Adding rational expressions. Rational expressions is a fancy word for a fraction. So let's say we had fractions. In order to add a fraction, you have to get the denominators to be the same. You find the least common denominator. Common just means the same. And you go through the multiples. So the multiples of 3 are 3, 6, 9, and 12. The timetables for 3. The multiples of 2 are 2, 4, 6, and 8. Now what do they have in common? They have in common the 6. So we ask ourselves, 3 times what will be 6? And you have to multiply that times a 2. And whatever you multiply the bottom by, you also multiply the top by. Now how do you get a 2 to become a 6? You have to multiply by 3. So times 3. But whatever you multiply the bottom by, you also have to multiply the top. So now we're going to have common denominators because 2 times 3 is 6 and 2 times 3 is 6. And when you simplify the numerators, you're going to get an 8 and a 15. And then you have to simplify these two expressions by putting the numerators together. And I'll show you that process. Let's say the denominator is a variable. Well, how do you then find the LCD? Let's keep looking at this. It'll be the same process. So let's say your denominators are x to the 4th power and x to the 2nd power. Okay, so the multiples of x to the 4th will be x to the 4th, then x to the 5th, x to the 6th, x to the 7th. Okay, those are your multiples, or the timetables for x. Here, the timetables for x, starting off with x squared, will be x squared, x to the 3rd power, x to the 4th power, x to the 5th power. Okay, now what do they have in common? Well, what they have in common is right here. It's the x to the 4th. So just like we did here, we'll find out how do you go from x to the 4th to x to the 4th. You have to multiply by 1, so times 1. What you do to the bottom, you do to the top. How do you go from x squared to x to the 4th? You have to multiply by x squared on the bottom and x squared on top. And now we get our new denominator of x to the 4th here plus x to the 4th there. That's x to the 4th. And this times this is x to the 4th. Same denominator. Now what's new on top is a 4 times a 1. What's new on which is 4. And on top here you have a 3x squared. Finally, we're going to do the same process when it comes to the x plus 3. You have an x plus 3 to the 2nd power and another denominator of x plus 3, forgot the 3, x plus 3 to the 4th power. So we'll look at the multiples and find the least common denominator again. So we're doing x plus 3's, the multiples of those, that'll be x plus 3 to the 3rd power. And next will be x plus 3 to the 4th power, and we'll do one more, x plus 3 to the 5th power. The multiples of x plus 3, starting off with x to the 4th power, will be x to the 4th power, then x to the 5th power, 3 plus x to the 6th power, and we'll do one more, x plus 3 to the 7th power. Now, what's common? What will be common is x plus 3 to the 4th. So that will be your common denominator for x plus 3. Okay, so let's look at these here. So we have a 4 over x to the 4th, and there's an x plus 3, and that's to the 2nd, plus 1 over x squared, x plus 3, and that's to the 4th. All right, we're going to create a common denominator for both of these. So we'll start off with the x's. We have an x to the 4th and x squared. When you start writing down all the multiples of this, which is x to the 4th, x to the 5th, x to the 6th, x to the 2nd, x to the 3rd, x to the 4th, x to the 5th, what will be common between these two will be x to the 4th. So we'll put an x to the 4th in both. Okay. Now, We have x plus 3 to the second power and x plus 3 to the fourth power. When you go through the multiples of all of these, what they'll have in common in their multiples will be x plus 3 to the fourth. X plus 3 to the fourth and x plus 3 to the fourth. And so we have now the least common denominator. So I'm going to put the 4 and the 1 back on top. 4 and 1. And let's find out the difference. X to the fourth here, x to the fourth here. No difference. X to the fourth here, but x plus 3 to the fourth here, and x plus 3 to the second. So there's two more x plus 3's that have been added to the denominator. So the difference is I have to put x plus 3, two of those extra on top to make up for the 2 that we added there. Okay, here we have an x squared, and now it's an x to the fourth. What happened was we have 2 extra x's in the denominator. So we have to put 2 extra x's in the numerator. And we have x plus 3 to the fourth, x plus 3 to the fourth. So we didn't add any more of these. So this is about it. So what we're going to do is now write everything with one denominator. The one denominator will be x to the fourth and x plus 3 to the fourth power. That's your least common denominator. And we're going to write down these two right here, 4 times x plus 3 to the second power plus, which is there. And then on this side, we have 1 times x squared. 1 times x squared can be just written as x squared. If you put the 1 there, it's still correct. We're finished. Let's go to the next one. Next one, we have a 3 over x minus 5 to the third power plus a 2x to the third power, x minus 5 to the first. Okay, so let's get the common denominator for these. So we have a 3 on top and a 2 on top there. So we have an x and an x cubed. So if I go through all my x's, I get x squared, x to the third power, x to the fourth power. If I go through my x's here, there'll be x to the third, x to the fourth, x to the fifth, x to the sixth. What they'll have in common will be x to the third power. Both of these will have x to the third power. And you notice a pattern that's coming. When it comes to finding the LCD for these variables, it's going to be the highest. The one that's the highest power will be the least common denominator. See, if you remember, when we went through the multiples, let's say x and x cubed. This starts off x, then x squared, then x to the third, and then x to the fourth. This starts off x to the third. The multiples are x to the fourth, x to the fifth, x to the sixth. And when you find the common will be the highest power. Okay. So let's keep going. All right, we have x minus 5 to the third and x minus 5 to the first. And when you write down the multiples, x plus 5 to the third power will be the LCD. So x minus 5 to the third, x minus 5 to the third. All right, so let's find out what's new. Here we used to have an x, now we have x to the third power. What's extra is 2 x's. So we'll put 2 more x's in the numerator. This had an x minus 5 to the third. This has an x minus 5 to the third, so there's no new x minus 5's. Here, this has an x to the third power. Here, x minus third power, so there's no extra x's. And x minus 5 to the first. Here's x minus 5 to the third. 2 more x minus 5 have been added to the denominator, so we'll add 2 more to the numerator. Okay, now we got common denominators. That means we can write everything with one denominator, x to the third, x minus 5 to the third power. And my numerators are 3 times x squared, which is 3x squared, then the plus. And here we have 2 times the x minus 5 to the second power. And we're finished. All right, lastly, looking at number 3. On number 3, we have 2 and 1. This is x, and this is an x plus 2. And that's to the third power. This is an x to the fourth power. And this is an x plus 2 to the fifth power. All right, so Now we're going to begin to find the LCD. All right, so 2 is already there, 1 is already there. All right, so here we go. We have a x and an x to the fourth. The common will be the highest power, so we'll write, or the least common will be the highest power, so x to the fourth on both. We have a x plus 2 to the third and x plus 2 to the fifth. What's going to be common will be the x plus 2 to the fifth, which is the highest power. So x plus 2 to the fifth and x plus 2 to the fifth. Now, let's see what's different. We had an x here, but now we have x to the fourth. What is new is that we added 3 more x's to the denominator, so we'll add 3 more x's to the numerator. The x plus 2's, there were 3 of them here, but now there are 5. So we added 2 more x plus 2's here. So x plus 2, 2 more. Okay, over here we have x to the fourth, so we didn't add any more x's. We have 2x, x plus 2 to the fifth, so it's 5 of them here. There's 5 of them there, so we didn't add any more. So there's nothing to be added to the numerator. So let's go ahead and find our result. The common denominator, or least common denominator, will be x to the fourth, x plus 2 to the fifth, and then all of this right here will be 2, your x to the third, parentheses, x plus 2, and that's all to the second power, then your plus, and then finally the 1 for this, and we're done.